Welcome back. Now this is one of the last topic, and after this we will be having one more lecture on groundwater. Now floods, okay, as we have been talking about that the hazard, natural hazard, this is one of the most important one which we experience every year, and they are seasonal. Okay, this the photograph in the backdrop which you see is of Brahmaputra river in its flooding condition during monsoon season. Now floods, if we take, there is another photograph of the Brahmaputra river which shows that it was in flooding state during monsoon season. Now floods, if we take in total, then they are the most common type of geological hazards and can be predictable. Now why this can be predictable? Because they are seasonal. So we have more number of data points which we can use and try to understand that how much rainfall is expected every year and how much area will be inundated, or the people sitting close or settled close to the river valleys or river banks will be affected. Now in total, if we take the hydrological cycle, what all parameters which are important, and because floods are created because of water, overflowing of water in river channels. So the important part here is that not only understanding the hydrological cycle, but also having some understanding of the landforms related to the river valleys or fluvial landforms, we will say, and of course the area in which we are living, that is the geology also, because the precipitation will not only when it comes on the surface, okay, in form of rain, then infiltration is one of the important parameter to talk about the runoff of the water, okay. And this will absolutely depend upon the subsurface geology. So this is again an important parameter to be understood. Okay. Now looking to the majority of the floods, they are linked with the amount of precipitation, that is either in through rain, or we are having the snow melt and all that. Okay. So water we can have either from the rain or from the snow melt. Then further, infiltration is extremely important, because if you are not allowing the water to infiltrate, you are allowing the water to flow over the surface, and that can lead into the overflow of the banks of along the river. So sink in the ground, okay. So percolates down, the water percolates down through soil, porous rocks, depends upon the porosity and permeability of the material. So this is extremely important in the area, okay. And highly porous rocks, if you are having, or the material you are having, you will have less runoff, leading to less amount of water available for the runoff, okay. And less permeable will allow more runoff. So in hard rock terrains, we will have more runoff of the water. So water we do not allow the water to percolate down, okay. Then of course along with that, the topographic influence on runoff is extremely important. So steeper gradients, we will allow the water to move as fast as possible. Less gradient, we allow the water to slow down, allow the time allows the water to percolate, but again it depends on the material characteristics, okay. Then further, the infiltration depends on the geology of the river basin. So we have the catchment area, watershed, and further we are looking at the downstream regions, okay. So, and other factors which are responsible for the infiltration other than the geology is the vegetation, where the vegetation may reduce flooding, provides physical barrier to surface runoff, decrease velocity of the water and reduce runoff. Plant roots make soil permeable by loosening it and increases percolation capabilities. Okay. So, these are few points which are extremely important, which eventually leads to the flooding conditions. Okay. Now, causes of floods, if we look at, then the most of the floods are through heavy rains, okay, in any area. Then we have some torrential rains, okay, or even we can say that the cloud bursts can result into the flooding. Tropical cyclones, as we have seen one of the example of Verda in the beginning of this course, which can lead flooding in the coastal areas and even in the inland side where the landfall is expected. Okay. Monsoonal rains, again snow melt can result into the floods. Then in some cases we have the release of excess water from the dam, which we can say that it could be a man-made flood, okay, or human induced flood we can say, and then breaking of levees and all that. And then we have, like for example, ice jam or the rivers which are blocked because of the landslide in the upstream. In the last lecture, when we are talking about the landslide, we talked about that if there is a blocking of a river channel in the upstream side, it will result into the formation of a natural dam, and if that breaks, you will experience floods even though you are not having enough of rainfall or heavy rainfall in that region. Okay. Then we have tropical cyclones, tidal surge, okay, avalanche related and all that. Okay. So, these are few of the cases which can result into the flooding events. Now, to understand the flood, it is important to understand the dynamic of river system, that is right from the upstream to downstream. Okay. Now, if you take a river or drainage basin, then what you expect is that from the source to the mouth, okay, how it traverses, what are the different landforms and how those landforms will be affected and where we can experience the flooding events. Okay. So, in if you take the river profile or the longitudinal profile, then you will find that, okay, in the steeper gradient in the upper reaches, where the river will always have coarser bed loads, but in the downstream side it becomes finer. Okay. So, in general the particle size may decrease downward, that is in the downstream side. Gradient decreases again. So, we are having steeper gradients in the upstream and we have a gentler gradient as we move towards the downstream side. Okay. So, gradient decreases downstream, however, discharge, carrying capacity and velocity increases downstream. This is true for areas with good rainfall, whereas in dry climatic zone, water is lost because of evaporation, infiltration, which results into decrease in discharge downstream. So, this is what you will expect in the upstream side, that you will have very turbulent flows and coarser bed loads. Okay. But as you move towards the downstream side, you will have very the discharge will be definitely okay in the sense, but the conditions in terms of the flow will be much less and it will carry finer deposits. So, from the upstream to downstream, the grain size reduces, okay, and also the landforms changes from place to place. So, steeper gradients will carry larger grains and the shallower gradients will carry the finer grains. Okay. Now, if we take the one of the branch of earth sciences, that is geomorphology, where we deals with the study of landforms mainly. Now, in terms of the study of surface, this is what is the definition. In short, we can say what is geomorphology: the study of surface feature of the earth which are sculptured or carved by river, winds and glacial actions. Okay. So, these are the agents which will carve the landforms on the earth's surface. Evolution and structure of various landforms related to mountains, plains, plateaus, valleys and basins are specialized field to study within geomorphology. And for a river particularly, what we say is fluvial geomorphology. So, we will see couple of examples of river landforms. So, in total, if we take the river system, what we have is we have the tributaries in the upstream areas. So, this is the watershed, okay, in the upstream area, or we can say the headwater area, and then we have the trunk stream and distributaries. Okay. So, through this journey where it flows through right from its emergence, it has different landforms. Okay. So, if you take the longitudinal profile here, you are having headward and you are having a mouth here. Okay. So, any water body it can meet, and tributaries will meet the trunk streams. Okay. So, if you take here this picture, what you see is that this is your trunk stream here flowing, okay, and then you are having smaller streams which are joining here. These are your tributaries. So, all are pouring water to the main trunk stream, okay, and this area is been termed as the watershed area or drainage basin. So, a river system consists of a main channel, that is what we termed as a trunk stream, and all of the tributaries that flow into it or joining the trunk stream. Okay. So, river system can be divided into three subsystems. One is the collecting system, that is we are having the branches, the network of tributaries in the headward region collect and funnel the water and sediments into the main stream. And then we are having, we can say it is a transporting system, that is the trunk. Okay. Trunk stream will be the transporting system. So, whatever the material has been collected or the water has been poured into the main channel, it will be further transported by the trunk stream, okay, which functions as a channel way through which water and sediments moves from collecting areas towards the ocean. Okay. Now, erosion and deposition also occurs in the river's transporting system, and then we say dispersing system. Okay. So, this we say roots. Okay. So, consist of the network of distributaries at the mouth which result into the formation of deltas, where the sediments and water are dispersed into the ocean, or it can be a lake also, or a dry basin where river finally ends its journey. So, stream flow and sediment transport, if you take, river is not a fixed structure like roads, subject to change their course under the influence of natural processes, and this natural processes is not only the internal one, but the external one also. Okay. So, internal as well as external can result into change of the course of many rivers. Okay. So, like for example, in the mighty Himalayan rivers, okay, or one of the name I would give here is the lost Saraswati. People are still trying to find out what were the causes for the shift of the Saraswati in the Indo-Gangetic plain, or why we lost the Saraswati, which used to debouch into then existing Arabian Sea in Great Run of Kutch. Okay. Right now that area is marked by Great Run of Kutch, and all settlements, okay, like Indus Valley civilization was flourishing or flourished along the Indus Valley and the Saraswati. Probably that was one of the main river which flowed during that period. Okay. So, whether the climate was responsible, which again we can say that is external process, or the tectonic activities, that is internal processes, were responsible for changing the course. Okay. So, it also influenced the human transfer from one place to another place. So, rivers are complex network, interconnected channels with tributaries, okay, respond to change, that is regional climate change or local weather or amount of variability of flow and sediment supply and size also. So, if you disturb this, it may result into the change of the river course also. So, channel patterns and fluvial landforms in total, if we take, okay, we have one is straight channels. So, in any drainage basin you will encounter this pattern of channels. Okay. So, where if you are having straight channel, then the maximum deepest part and the maximum energy will be in the central portion of the channel. Then we have the braided channels, where again it is a combination of several straight channels, or it may be in combination of meandering channels. Okay. So, it joins and flow through the river valleys. Okay. So, we have like meandering also. I will come to this in coming slides. Okay, meandering rivers, but in meandering rivers are like a curved, it takes curved path, or we say sinus path. Okay. And mostly you will find this in the lower reaches or the downstream side. So, braided river system, okay, exhibits numerous channels that split off and rejoin, okay, each other to give a braided appearance. Okay. They typically carry coarser grain sediments down the steeper gradients. Okay. These are the examples of the braided river. So, it may be straight or it may be multiple meandering channels. Okay. Now, meandering channels, usually what we will find. So, I will just talk about this one before we go to the meandering channels. The landforms which we see here are the braid bars. Okay. So, these are the braid bars which are sitting between the two adjoining channels. Okay. These are all braid bars, or we can say the island, because it has been covered from all sides by water. Then meandering channels, it has a capability of deposit and erode. Okay. So, on the inner side of the curve, it will deposit, and the landform which is generated by such activity is been termed as point bars. And this portion, that is the outer side of the curve, it will erode. Okay. So, this is an erosional part. Okay. So, you have erosion here, you have deposition here. So, you generate landforms, you erode the areas. Okay. And the erosional sides will have particularly higher cliffs. Okay. So, it will have cliffy banks, whereas on the depositional side we will have the formation of terraces. Let us see some examples of this. Another important part which I would like to mention here is that the part which is the outer side, okay, will be deeper and will be having higher energy conditions as compared to this one. So, what you see here is that if you take a channel, okay, which is flowing here like this, okay, and you have some portions you have straight channels. So, if you take the cross section you will find something like this, but if you are having the meandering and if you take this, so this portion will be the deeper part, okay, and will have the high energy conditions. Similarly, on this side you are having, this side is an erosional one, and deeper part again you are having straight channel here. Okay. So, this will result into the formation of point bars. These are what are been shown as in point bars, and these are the outer side which you can see the cliffy banks over here. And we will see, we will talk about the formation of different landforms here. Now, this is very typical, we will see or observe in the plain areas, for example, like in Indo-Gangetic plains. Okay. What are these landforms and how they are created, we will talk about that. So, we have the different landforms which are associated with that. An important one close to the river channel is the levee. Levees are basically, if you look at the cross section here, then you will find that then these are like slightly elevated, and then this is your river valley, and then you are having this is going on. Okay. So, slightly elevated portion close to the river banks are termed as There is another example of the sinus river or meandering river. So, meandering rivers have capability of shifting and leaving behind some of the landforms which eventually will get in will get converted into the backswamp or the wetlands. Okay. So, you will also find in Indo-Gangetic plains lot of wetlands and backswamp areas which are the result of the migration of shifting of the meandering rivers. So, in contrast to the braided rivers, meandering rivers typically contain one channel that winds its way across the floodplain. As it flows, it deposits sediments on the banks that lie on the inside curve and result into the point bar deposition and erode the banks on the outside curves, okay, which will result into the formation of cliffy banks. So, this is what I was talking about, that if you take the total view of the meandering dynamic, okay, then you will find that this part, that is the outer side which is eroding, will be deeper and will have higher velocities, okay, whereas this will act as an accretion ridges, okay, forming gently and moving towards this side. Okay. So, we will have the migration of the point bars here, and this channel will keep on eroding this side. Okay. This is an example of that. So, you have the older channel over here which flowed earlier, and this is the boundary of that, and now it has migrated over here. Okay. These are termed as point bars, and the deepest and the steepest portion, okay, with greater energy is been termed as thalwich. So, this portion you see here, okay, will be the deepest part, which is termed as thalwich. Now, this what I was trying to explain you, that you are having the how the oxbow lakes are formed. Okay. So, you are having the meandering channel here, which is flowing through this like that, okay. And then we have the outer side on this side and this side, okay. So, this will keep on eroding like this will keep on eroding towards like this, okay. And finally, it will result in the cutoff channel, okay, and leave behind a landform which is very much similar to the foot of the ox, okay. Hence, it is termed as the Oxbow lake. These are the example of that. So, this is an Oxbow lake which are been termed, okay. So, earlier the channel flowed through this over like this and might be going like that, but now it is flowing through and through. Okay. So, this is termed as the Oxbow lake. Example of that. Now, this is already the Oxbow lake is formed. The next Oxbow lake will form here, okay. The river will be connected like this, okay. It will flow through and through like this, and this will be in another formation of the Oxbow lake. So, in the plain areas you can see the remnants of the Oxbow lake. This is one here and this is another one here, okay. So, if you look at again the cross sectional view of the meandering channel and the straight channel, what you find is that you are having here, okay, the coarser bed loads, okay, and in the point bar areas you are having medium to fine and very fine deposits. So, this portion is having higher velocities, okay, and of course, having the deeper portion here, shallower on this side. So, you can compare that the deeper portion high energy coarser bed load, and the shallower one you are having finer deposits along that, okay. Again, this explains the same what we have discussed, that slowly this will join and will leave behind the formation of ox shaped, okay, the foot shaped feature which is termed as the Oxbow lake. So, let us look at one of the photo, satellite photo of the Gangetic plain. Now, this is the photograph which shows the meandering channel, and along with that what we see is this is an active channel which is presently carrying the water and sediments, whereas other than that we have few older meanders which can be seen on the banks of the river, and then we have some portion which are little bit with the darker shades, and this marks the older floodplains, and in between those two are marked by the active floodplains, okay. So, here the important part is that we also need to know that which areas are the active floodplains, even though the river is not flowing at that particular point, okay, at present, but can reoccupy those regions in future also, okay. So, river have capability to migrate. So, for example, this area is right now is within where no water is flowing, because the active channel is over here, but it can reoccupy this also, okay, because these are all the low lying areas close to the river channel. So, these are the older floodplains, okay. Moving further, again what we see is along with the meandering channels and the straight channels or braided channels, we see this landforms which we call the terraces, okay, and terraces are nothing but the abundant floodplains of the river valley, along the river valley. So, active stream is flowing here, and earlier the stream flowed along this one, okay, and then slowly it has eroded and resulted into the formation of terraces, okay. And close to the banks we have slightly elevated portions which are termed as levees, okay, natural levees, but in field it is most of the time bit difficult to mark it, but you can see this type of things. Okay. Now, when the river is in the flooding condition, as I was talking, that it can occupy the the older floodplains also, which we were talking about, like for example, the abundant floodplains. Okay. So, during the bankful flows, it can reach and inundate the areas like this. Okay. So, what you see in the figure B, we are having that it has left out the older terrace, but the younger terrace over here, these are the younger terraces, they have been submerged. Okay. So, if you are having the settlements without having the much of understanding here, okay, you are constructing your houses here, then you will face problems, okay, during the flooding events. So, you need to understand that how big floods were being experienced in the past by along this channel, and so accordingly you can have the town planning. Now, river and related landforms, we will quickly look at the landscape. Again, what we are looking at here is the floodplain, and this is natural landscape, but if you try to channelize the flow, okay, to avoid the flooding in the low lying areas where you have allowed people to settle down, then you can have this one. Okay. This is what we call the construction of artificial levees, okay, and then you can allow the people to stay in the neighboring lower terraces. Okay. So, you have channelized the flow by constructing the levees. Okay. I will show some examples where there are big cities which are sitting close to the major rivers. Okay. Now, alluvial fans and deltas are another landforms which are related to the fluvial activities. Okay. So, alluvial fans are usually seen when a stream flowing through a steep valley in uplands debouches suddenly onto a newly or nearly flat valley floor, or we can say the alluvial plains. Likewise, we are having Himalayas and we are having Indo-Gangetic plain. So, close to the like we are having like this mountain front here, and then we are having, so close to the front we will have the formation of alluvial fans. So, it experiences a decrease. Why the alluvial fans are formed? Because it experiences a decrease in the slope, okay, a corresponding drop in the velocity, and a decrease in its ability to carry sediments. Okay. So, because river is coming from the steeper slope to the gentler slope, it will drop there will be drop in velocity, okay, and also it will have less capability of carrying the coarser bed load. So, it will dump everything at the base of the mountain front. So, as a result, the stream deposits its load in a fan like shape. So, at the base, if you are having this as a mountain front here, so at the base you will find the lobe shape features, which is very much similar to fan shape, hence it has been termed as alluvial fan. Alluvial is the all loose material. Okay. This is an example where you are having this is a very well known city, Chandigarh, and this is what you are having, the front, Himalayan front, and at the base here this is what we are having, the alluvial fan. Okay. Now, hazard related to this landforms are that close to the front, that is what we call the proximal part, will be highly hazardous. Okay. In this area, the channel will have capability of depositing very coarse bed load. Okay. But as you move away in the fan region, then you will have finer deposits. Okay. So, close to the proximal you will have coarser bed load, away from the proximal part, that is what we call the distal part of the fan, you will have finer deposits. So, if you take in terms of hazard, the proximal part will have high hazard, then moderate hazard in the medial part, and then you are having lower hazard in the distal part. So, again this is an example of that. Okay. So, you are having the mountain front here and you are having the deposit of the, that is the alluvial fan deposit. Further, another example from the Himalayan front, you can see multiple formation of the fans here. Okay. These are all the coalesced alluvial fans. Okay. So, stream is coming from the confined areas, getting unconfined on the gentler slope. So, this side the slope is steeper and resulting into the formation of alluvial fans. This is in desert area, and this what we see, either you can call this as a delta, okay, or a fan area close to that. Okay. So, alluvial fans are fan shaped deposits of water transported material, that is what we call alluvium. They typically form at the base of the topographic divide, where there is a sudden break in the slope. Consequently, alluvial fan tends to be coarser, especially at their mouth, that is the distal the proximal part, and at the edges they will become finer. Okay. And the Piedmont zone, a slope surface at the base of the mountain formed due to erosion covered by thin veneer of alluvial. Okay. So, this portion will be termed as the Piedmont zone. Okay. We are having. So, here you will have coarser sediments, here you will have moderate sediments in size. Okay. You are here we are going to have the finer sediments. Okay. So, this is what we have the confined areas and then higher steeper areas, and then river flowing down to the gentler part. Okay. So, you have free face here, and this is the area where alluvial fan will be deposited, and the region of this part, that is at the base, is termed as the Piedmont. Now, coming to another important landform, which is delta, and this usually are seen where the stream enters the standing body, either it is a lake or it is a basin, or we can say it is in the ocean. Okay. And here its speed drops rapidly, its ability to transport sediment decreases, and it deposits the solid loads. Okay. And fan deltas typically is built adjacent to the mountain fronts, okay, and the braid deltas, okay, in are usually the coarser grain deltas constructed by the braided stream that build outward into the standing body of water. So, this is what one can see. Okay, close to the front you may have the fan deltas, okay, and then you may have the braided deltas. Okay. So, for example, you have many of the world's largest one, okay, and the massive deltas. One is from the Indian subcontinent, the Ganges Brahmaputra delta. Okay. So, distributary are long here, finger like, okay, channels that branches from the main stream. Okay. So, this is almost like the inverted part which we were talking about, that if stream is flowing like this. Okay. So, initially what we are having the collecting one. So, you are having the drainage here, whereas at the end it will disperse like this. Okay. So, these are what we see, the distributaries. Okay. So, this will result into the formation of delta, and this is the watershed area here we are having. So, this is a similar example what we were talking about, the deltas. And this is the delta forming into the lake. Example of one of the largest one, okay, the Ganga and Brahmaputra river. Now, this is an example which I would like to quickly discuss, is the hazard related to the alluvial fan. Okay. and this river which you see here is the Kosi river, and which experiences most of the time experiences the floods during monsoons, and this part is marked is the Himalayan front. Okay. So, you are having the Himalayas here, and that is the Shivaliks, and you are having the Indo-Gangetic plain, and the shape, if you take this one here, this is very much what we were talking about, the fan shape. Okay. So, the present day river, it flows along this path, okay, but it changed its course in 2008, it flowed through this. Okay. And if you see some lighter lines here, okay, and some features here which I was talking there, you can see the meanders here. Okay. So, these are all the part of the active flood plains. Okay. And in 2008 it flowed through somewhere through here, this region. Okay. It took its or reoccupied its own channel. So, I will stop here and we will continue in the next lecture.